only come out of the water because in November when it was slipped, it's now the start of February and we have significant level of growth. There was no other reason why he was slipping his boat. So when we're testing to see what's connected to an anode, a really simple test is a continuity test. So when the boat's out of water, we're wanting a good multimeter and we're using ohms. And we get a really good hard connection on the anode here. So what we've got set up on this boat is an IPS that's protected by an ACP. This should be isolated from the rest of the vessel because that ACP system is designed to look after the pods only. So if we do a test, we go between the anode and we've got kilo ohms of resistance. So we know that these two systems are isolated. So if we go between this anode to the drives, we have again 70 kilo ohms of resistance. So that will be the same across both IPS pods. So we know that those IPS are isolated to the rest of the bonding system and the ACP is doing the job of protection. Right, so the first things first, we're going to see, okay, well what's bonded to this anode? We've got this strut here to support the swim platform. And if we get bare metal, we want to get a really good connection. Underneath the oxidation, we have closed circuit, so it's absolutely continuous. We go over to the trim tab. Again, we have absolute connection between that anode. So that aluminium anode is protecting this trim tab. We go to the outer arm here of the swim platform, or the transom assembly here. We have very good connection. It's just hard to get under the paint.
Going to the anode.
Yep. Now, if we go onto the Maddox anode that's been installed onto this boat, again, we get under the oxidation. We have open or closed circuit. So we have connection of the aluminium high potential anode to the Maddox. That's why the Maddox is not working. Now, if we go over to this arm where the coating is completely different to the rest of it, the rest of the boat, we have mega ohms of resistance. So this anode is isolated from the rest of the swim platform. It is isolated from the bonding system. This anode has been creating the protection, okay? And that's why we've got the coating in a much, much better condition compared to when we're protecting stainless steel with a high potential anode material. So this is a really great case study to show that what can happen in 3 months in terms of growth and the effect that anodes or high potential anodes can have on very low potential stainless steel bronze when they're overprotected. So a really quick check with your multimeter to see what's connected to what is going to be a really great tool to make sure that we know what anode is connected. We need to make sure that whatever is connected together needs to be the same type of anode material. So what we're going to do on this boat is we're going to remove the aluminium anodes on the back here. We're going to replace them with Maddox. That means that everything that's connected is going to be working together, and we'll have a much better result for this customer in terms of his paint performance and lack of. So I think all in all, this will be a really great result for the customer, and we'll check back with him in about 12 months' time.